Hey everyone, so today we're going to focus on finding the derivative of a product of functions. So in our last lesson we talked about how if you have adding and subtracting, you can find the derivative of each piece individually and then just add them or subtract them. That's not the case with products though. So pause the video and do this practice AP problem. So we are approximating 8, right? So whenever you approximate, that's your average rate of change. So that's f of b minus f of a over b minus a. So since it's 8, I'm just going to use the numbers on either side, 7 and 9. The average of 7 and 9 is 8, and that's important. If they gave you like 7 and 10, you might have to use different numbers. All right, so I have f of 9 is 54 minus 60 over 9 minus 2. It's just slope, negative 6 over 7. And then, let's see, my x. The length of rod is heated at one end. The table below gives the temperature in degrees Celsius. So it's degrees Celsius per centimeter. So that represents the average change in degrees Celsius for every centimeter heated, right? So it's the average change in degrees Celsius per centimeter at 8 centimeters. So it's just the average change, basically. Okay, so find the derivative, really basic derivatives. Find these three. So here, f prime is 2. G prime is 3x squared. And h prime is 8x cubed. Now, if you notice, f times g is 2x to the fourth. If I take f prime times g prime, what do I get? I get 6x squared. That is not the same as this. So this is just showing you a really basic example that if you are breaking things up into multiplication, you can't just take the derivative of each piece and then multiply it together. You get very different answers, right? 6x squared, 8x to the third, very different. So what do we do when we're going to learn how to find the derivative of something, the shortcut? We start definition of the derivative. Again, don't freak out. It's okay. I'm not expecting you to do this yourself, but I want to show it to you. So we're doing our difference quotient. I don't even have my limit in here. The limit as h approaches 0, right? We replace f of x and g of x with f of x plus h, g of x plus h, minus... Right, so we're looking at this. This is our difference quotient. Now, here's the thing with this one. It's like I don't know how they came up with this. I have no idea. Mathematicians are super crazy smart. So the mathematicians decided we're going to subtract f of x plus h, g of x, and then add it in as well. So they're adding and subtracting this term, f of x plus h and g of x. Why they decided to do that, I have no idea. But the mathematician said that's a good idea. So now what we did is we just took that, right? So we're looking up here. All right, so look up here. Focus on this. All right, so then they took that big thing and they broke it up. So these are the first two, and then these are the second two. And when you're dividing, you have to keep the h. So we have this piece plus this piece. So we broke up that big thing into two different parts. So now if you look at this, both of these have an f of x plus h, f of x plus h. So what we're going to do is we're going to factor it out. So down here we factor out the f of x plus h. And then when we factor that out, we're left with g of x plus h minus g of x. All right, so f of x plus h, and then g of x plus h minus g of x. But then notice, what is this? This represents something. That's a definition of the derivative. Whose derivative is that? That's the derivative of g. So that's g prime of x. Okay. So same thing with this other one. In this one, we have our f of x plus h g of x. This time we can factor out g of x, right? So we factor out the g of x, and we're left with f of x plus h, f of x, all over h. So then similarly, we have this. That's the definition of the derivative of f. That's f prime of x. So we end up with the limit as h approaches 0 of f of x plus h times g prime plus the limit of g of x times f prime. So what do you get when you plug 0 in here? So we end up getting here, that just gives us f of x, and then we have that times, this times right here, that g prime, because that's the definition, plus g of x, right, this piece, that we can't plug in 0, nothing happens, times f prime. And this is called the product rule. All right. So the product rule is basically saying if you have two functions and you are multiplying them together, this is our formula. It's the f prime times g plus f times g prime. And in my head, I think of it as the derivative of the first times the second plus the first times the derivative of the second. So it's derivative, keep it the same, plus keep it the same, derivative. And that is your product rule. So I'm going to write it at the top. So f prime g plus f g prime. So the first thing I'm going to do is I'm going to look at my problem, y equals. So I'm going to call this my f and this my g. Now this one's a little overly easy because what's the derivative, of e to the x? Derivative of e to the x is just e to the x. All right, so why is it disappearing? Y prime equals. So the derivative of the first, what's the derivative of our f? 2x times g, which is e to the x, plus, we're going to keep it the same, 1 plus x squared, f stays the same, and then the derivative of e to the x, which is just e to the x, and that's our answer. All right, number 2. Now, the number 2 is a silly one. Kids do the product rule for this all the time. However, this isn't really a product rule because my f is a constant. So you don't really need to do a product rule here. I think it's really silly to do that. I would honestly just distribute 5x squared plus 5. So then f prime is 10x. Now, can you do a product rule? Yes. It's just really, really weird. If we were to do a product rule, the derivative of 5 is 0 times g plus, leave the 5 alone, derivative of g is 2x. That's just like an overly complicated way of doing it. So if one of your functions is a constant, I would not bother doing a product rule. That's just silly. All right. So I want you to pause the video and try these. So really focus, f prime g plus f g prime. All right, so I always make the first one f, the second one g. So now this first one, number 3, if you want, you can distribute. It's a pretty easy problem to distribute, and then you don't have to do the product rule. It is up to you, though. So I'm going to do the product rule first, and then if you distributed, we can go over that too. So I know it's weird because the name of this function is f, but then I have f times g. So if you want to do like g and h, you can do that too. I really don't think of them as f and g. I think of them as the first and the second. So the derivative of the first, 5x to the fourth, times the second, plus the first, times the derivative of the second. So because you could easily distribute there and rewrite it as x to the 6th plus 2x to the 5th. So if you do that, if this were me, I would probably do it this way. We don't know a lot yet, so sometimes when we learn product rule, it's kind of a silly method because there's other ways to do them. As we learn more derivatives, like we're going to learn the trig derivatives next week, it makes a little more sense. All right. Now, these you could distribute out, but I would never do that because that's terrible. Like, I don't want to just FOIL that out. That's terrible. So, derivative of the first, 4x cubed minus 3 times the second. We'll do that in red. 9x squared plus 17x minus 1 plus the first. Rewrite it. X to the fourth minus 3x plus 2 times the derivative of the second, 18x plus 17. Now, we're not going to multiply anything out. We're just going to leave it like that. You don't have to simplify these. The only time I ever simplify with this stuff is if I need to use it for something else later. All right. Derivative of the first, 3e to the x plus 7 times the second, 12x to the fifth minus 9e to the x plus the first, rewrite, derivative of the second. We're doing black. 60x to the fourth minus 9e to the x. That's it. All right, pause the video. Try this on your own. So these are only hard because of the negative exponents. So g prime, oh no, don't move. G prime equals derivative of x to the negative 3 is negative 3 x to the negative 4. Leave the second function alone. Again, unless you wanted to distribute, you can. Plus, leave it alone. Derivative of the inside. Oops. Derivative of 9x squared is 18x. And that's it. Again, this one, these wouldn't be, well, I wouldn't distribute this because if you did distribute, you would end up with a product rule anyways, because you would have, that would be 4x to the negative 3e to the x minus 9x to the negative 1. So you would have a product rule right here anyway, so I don't really see there's no benefit in multiplying out. You can, but you're just going to have you'll end up with a product rule anyways. Okay, I went through and I locked this, but it's not working. Lock. Alright, hopefully it works now. Alright, next one. H prime. So this is my first, and then that's my second. So negative 10 x to the negative third. Leave the parentheses alone. As you can see, these can get really long. And then plus, rewrite the first one. That's an x, just kidding. X to the negative 2, and then the derivative of the inside. Negative 51, x to the negative 4. Don't forget when you're subtracting, negative 3 minus 1 is negative 4. Plus 88, x to the 7th. Derivative of e to the x is e to the x. And that's it. All right, last one. Okay, so sometimes on the side, when you're first learning these, you might want to rewrite 6 over x to the 4th. So 6 over x to the 4th is 6x to the negative 4th. So maybe go through and do the whole thing with that first. So f prime, derivative of that is negative 24 x to the negative 5 times my parentheses. And then I'm going to rewrite. I'm going to leave it 6 over x to the 4th, because I'm leaving it alone anyways. X squared plus, just kidding, you have to take the derivative of the second, 2x plus 3. 2x plus 3. And then typically with these, because it gave me that fraction, I'm going to put this back in. Not a ton of room. But I would rewrite my final answer with that negative 24 over x to the 5th. X cubed plus 3x plus 2 plus, and then you can make this one big fraction. You could have made it one big fraction if you wanted. However you want to write it. But usually if they give it to me as a fraction, I put it back that way after I take the derivative. All right, last one. Now this is a triple, so I want to see if you can figure it out. So try it. You have, say, f, g, and h. So what do you think the derivative of f, g, h is? So it would be the derivative of the first, leave the second two, and then the first derivative of the second, leave the others, and then the first two, derivative of the third. So it's not really out there. All right, so the derivative of the first is nice. It's just that since the derivative of e to the x is just e to the x, we're really rewriting just this whole thing. So we're going to end up going on to 2 different pages because this is two different lines. So that's the first plus, I'm just going to go to the next line now. E to the x, the first, derivative of the second, times the third, plus the first, the second, and then the derivative of the third. That's the answer. I can't really, I mean, if you have a big paper, you can write it all in one line. It looks better that way, but that's it. I'm not doing anything with that. I guess you could factor out the e to the x. There is ways to simplify it, but there's no purpose. So I'm just going to leave it. All right, there's homework 22. Again, it's just like practice, like get good at using these formulas.